All right, we are going to start by going over the additional examples for day 3. So looking here at my first table, we have to find the slope. Remember slope, just a fancy way for saying the rate of change. Change is the change in the dependent over change in independent. So I always start by just looking at 2 points and I say, okay, from -3 to 3, that went up 6. And from -1 to 2, that went up 3. I'm going to just double check one other one to make sure I'm on the right track. From 7 to 15, that went up 8. From 4 to 8, that went up 4. Well, if I take 6 over 3, that's 2. 8 over 4 is also 2, so my slope would be 2. You could also write it as 2 over 1 if you wanted to. Now, the y-intercept is always when x is 0. Well, if I look here, I can't find that y-intercept. Again, y-intercept, sorry, was start. So I need to figure out on day 0 what it would be. Well, if I know it's changing 2 every 1 day, so to go up 1 day, this must go up 2, so that'd be -1. So my y-intercept is -1. To put it in the equation format, it's y equals mx plus b, where m is my slope and b is my y-intercept. So y equals 2x plus -1. Remember, x and y stay x and y because they represent that there's infinite coordinates on the line. Okay, looking here, we'll start with the easiest. The y-intercept is where it crosses the y-axis. I see it crosses it there at 5. To find the slope from the graph, I always think of it, how much do I have to go up or down and to the right to get from one coordinate to the next? So I'm going to start here. To go there, it looks like I go down 1, 2. So I went down 2, and I have to go over 1, 2, 3, and over 3. So I would say it is -2 because I went down, and over 3 would be my slope. Then my equation would be y equals my slope times x plus my y-intercept. All right, number 3, y equals 4x minus 11. Well, this one we just have to look and identify the parts. The slope here would be 4. The y-intercept, usually this is a plus sign and it looks like they changed it to minus. So if I chop chicken, that would make that -11. The equation's already there, so we don't need to do it. We're done. Okay, number 4, Thomas got a speeding ticket last weekend. He had to pay $275 for going 16 miles over the speed limit. Jenny also got a speeding ticket and had to pay $205 for going 9 miles over the speed limit. Identify the variables, which just tells me what does each mean. Find the slope, y-intercept, and equation. Well, to start, we need to figure out what's going to be our independent and dependent. So what has to occur in order for the other? Well, you don't have to pay in order to go fast, but if you go fast, then you get charged for paying. So it looks like that miles is going to be my independent, and money is going to be my dependent. If you remember back, x is always independent, y is always dependent. So I would say x is the number of miles over the speed limit, and y is going to stand for money. All right, this one's going to take a little work here. So if I'm going to look at the slope, I like to kind of put these in a table. And I know that when they went 9 miles over, it was $205. And when they went 16 miles over, it was $275. So I have to figure out what is that rate of change. Well, it looks like it increased $70 for an increase of 7 miles. So I would say my slope or rate of change is $70 over 7 miles, which is $10 per mile. So my slope is 10, or you could put 10 over 1. Well, my y-intercept, so it's like this person, you have to pay for each mile you go over, but you also have to pay for the ticket too. So we have to figure out if you went 0 miles over, which doesn't really make sense, but what would it be? So I need to kind of go back 9 miles and figure out how much that is. Well, if it's $10 per mile and I'm going back from 9 miles being 205 to 0 miles, that means I have to go back 90. I got that because 90 over 9 would be equivalent to 10. So if I go back $90, so 205 minus 90, 105, 115. So that means my y-intercept or my start would be $115. Now my equation is y equals the slope times x plus the start. That's one of the toughest problems that you're going to see. That was a hard one. There was a lot of pieces involved in that. All right, now these are a little more straightforward on 5. It's just how do you find the slope? If you remember, there was this equation of y2 minus y1, which just tells me how do my y's change over x2 minus x1 over how do the x's change. This most teachers use. You know, Miss Terry, I'm a little crazy. I prefer to use it in a table format. So I just say, okay, 4, 5, that's my xy, and 6, 11. And I say it went up 6 in 2 days. So my slope is 6 over 2, which is the same as 3. Okay, I'm going to do another in my table format. -4, 9, -6, 13. It went up 4, and be careful here, if it was a -4 and -6, it went down 2. So my slope was 4 over -2, which is the same as -2. Okay, put it in my table format. 5, 11, -7, 11. It went up 0 and it went down 13. So it's always my change in y, so 0 over -13. And this is where you kind of have to stop and say, okay, there's a 0 involved. Is that a undefined slope or a slope of 0? Well, what makes undefined is having 0 in the denominator. I don't, so that means this must have a slope of 0. Which works because I can take anything and divide it by, I can take nothing and divide it by a number, but I can't take a number and divide it by nothing. All right, number 6, how can you determine if the slope is going to be 0 in a graph, equation, or rate of change? Well, in a graph, the slope would always be 0 if it is horizontal. So that's probably what I would say, is horizontal lines always are 0. Okay. In an equation, oops, sorry, probably want the L there. An equation, if you think of it being 0, it'd be like y equals 0x plus, I don't know, I'm just making up a number 4, which that could also be just y equals 4. So I would say if there's only y and no x, that would be the equation way. Rate of change, I'm just going to refer back up to here. If I have 0 up here in the numerator, then it's going to equal 0. So I'm going to say 0 in numerator. All right. How can we determine if the slope is going to be undefined in a graph equation? Well, for undefined, it's always going to be a line like that, which is vertical. So I would say vertical lines on the graph tell me that it's going to be undefined. The equation, well, if I look at all these coordinates, let's say that that is 5, 3. This would be 5, -1, maybe 5, -3. They all have the same number for x. So like the equation of this line would be x equals 5. Because y is constantly changing, but x is always staying the same. So if we have that, our equation is always going to just be x equals a number. So maybe that's what I'll put, only x and no y. That tells me that it is going to have an undefined slope. Then for rate of change, what really makes that rate of change undefined is by having any number on top and by having 0 in the denominator. That is what's going to make it undefined. All right, hopefully that helps you guys. Good luck.